Hello friends, you are watching our channel SB EduPoint. Hope you all are doing good. Please stay home and study well.
Friends, in this video, we are going to talk about polygons. Next will be the classification of polygons based upon the number of sides. Then we will see about the diagonals of the polygon and how to calculate the number of diagonals in a closed shape. Then we will talk about the concave and convex polygons, how we will differentiate them. Lastly, we will see the difference between the equilateral, equiangular and regular polygons.
So friends, let's start to our session. And in this video, the very first thing we are going to discuss is what are polygons. A polygon is a simple closed curve made of at least 3 or more line segments is known as a polygon. And if we see to the word polygon, it itself describes the meaning that poly means many and gon means the sides. So basically a polygon is a simple closed curve which is made up of only the line segments. Now if you can see, there are curves which are simple and closed, that is why these are the polygons, and to the right there are curves but these are not simple as they are crossing themselves, that's why these curves are not to be the polygons. Now we will classify the polygons based upon the number of sides or vertices they have. So the first one is the trigon or the triangle consisting of 3 sides or vertices. As we have already discussed in the first slide that a simple closed curve needs at least 3 line segments to form a closed curve. So you can see the sample figure of the trigon. Next, tetragon, or you can say the quadrilateral, having 4 sides, like you have rectangle, square, rhombus. These are the quadrilaterals. Then comes the pentagon, having 5 sides, or you can say the 5 vertices. Next, hexagon. Hexagon, as you can see in the figure, has 6 sides. Next comes the heptagon, octagon, nanogon and decagon and so on. Is a line segment linking two non-adjacent vertices of a polygon. Here, as you can see, I had taken the example of a rectangle and I had mentioned the vertices as A, B, C and D. Firstly, I will talk about the line AB. AB is the line connecting two adjacent vertices. That is why it will not be considered to be the diagonal of a rectangle. Next, as you can see, a dotted line connecting the vertices AC is the diagonal of the rectangle, as A and C are the two non-adjacent vertices. Similarly, the line joining B and D will also be the diagonal of the rectangle, as B and D are also two non-adjacent vertices. Hence, we can conclude that the rectangle has two diagonals. To explain you more about diagonal, I have taken the second example of triangle. But before moving on, I had a question for you all. What do you think, friends, whether there is any diagonal present in the triangle or not? Please do write your answer in the comment section. Now we will going to see whether your answer is correct or not. As you can see in the figure, I have taken a triangle and I had named the vertices as A, B and C. First we are going to see whether the sides of the triangle are considered to be the diagonal or not. But we have already learned about the diagonal, that it is the line segment that connects two non-adjacent vertices. So the triangle doesn't have two non-adjacent vertices. That is why we can say that the triangle doesn't have any diagonal. Secondly, I had drawn a dotted line which you can see that connects the vertex A and the point P, which is the midpoint of the line BC. It will also not to be considered as the diagonal because it is not connecting two vertices. Hence, we can conclude that triangle doesn't have any diagonal. So the next topic which we are going to see is the formula to calculate the number of diagonals of n-gon, or in general we have the formula for the diagonals of the polygon. As we have already seen the example of triangle and rectangle in our previous slides, but what is the need for this formula? If we have a curve with the sides 8 or 10, then it is not possible for us to draw that curve each and every time and then check how many diagonals are being formed inside that curve. So for that reason, we have this formula to easily get the number of diagonals. For example, firstly I have taken an example of a pentagon with 5 sides, and I had calculated that the pentagon has 5 diagonals. Secondly, I had taken the example of an octagon. An octagon consists of 8 sides. So 8 into 8 minus 3 whole divided by 2 will give us the result, that is 20 diagonals. Next we will discuss about the area being covered by a polygon. Firstly, as you can see on your screen, I have taken a rectangle, and all the part or the area that is being covered inside is shown by the blue color is known to be the interior area of the rectangle, whereas in the second picture the blue part which is covering outside area of the rectangle is known to be the exterior area of the rectangle. So you will get an idea what is the interior part of the polygon, and next what is the exterior part of the polygon. Next is the classification of polygons as convex polygon and concave polygon. As you can see, I have taken an example of a rectangle in convex polygon and I had mentioned the diagonal as a dotted line. Secondly, I have taken a figure, and as you can see, these are the two non-adjacent vertices, and the line segment connecting these two adjacent vertices will be the diagonal. So we can differentiate these polygons as in convex polygon, no portion of the diagonal gets in the exterior area of the polygon, whereas in concave polygon, as you can see, the diagonal lies in the exterior part of the polygon. Another point that differentiate these two polygons is that in convex polygon, none of the interior angle will be greater than 180 degree, whereas in case of concave polygon, at least one interior angle will be greater than 180 degree. The last topic of our video is the classification of polygons based upon its sides and angles. So first one is the equilateral polygon. We define the equilateral polygon as a polygon which has all of its sides which are equal in length. So the example is of rhombus. As you can see in the figure, each of its side is of 2 units. So it makes the rhombus an
example of an equilateral polygon. Second is an equiangular polygon, a polygon whose interior vertex angle are equal is known to be the equiangular polygon. Example I have taken is of rectangle, where you can see each angle of a rectangle is of 90 degree. Each interior or vertex angle is of 90 degree, which makes this rectangle as an example of a equiangular polygon. Last is the regular polygon, a polygon whose sides and angles are equal, which means both equilateral and equiangular are known to be as a regular polygon. For example, a square which has all of its size of 2 units and the interior or vertex angles as of 90 degree, which makes the square as an example of a regular polygon.
Thank you so much friends for watching this video. I hope you all liked it, and please do share it with your friends also, and don't forget to subscribe our channel.